Okay, making Tic Tac Toe again, but this time focusing on trying to build it using a few more techniques, and this is geared in particular for my grade 11 students who will be trying to build Tic Tac Toe without all of these variables here. It's not a bad way to start. If you've new to this, then by all means, but let's try to do it using something a little more flexible, a little more powerful. You can imagine if you were trying to do a game like Connect 4, for instance, which has a much larger game board, that you'd be really frustrated trying to manage this by using variables for tracking the state of each position on a game board that might be a lot larger. So let's look at doing something with lists, and I started out talking about I'll start out with this. So I'll just make a variable here called nums, and I will create a list. So what is a list? Because I'm assuming that at least for my students, we didn't have a chance to talk about this yet. So a regular variable is able to store a single value, and of a particular type, an integer, a single value of an integer, perhaps a Boolean value, a string. We've dealt with all of those in our classes. So there's a variable that's a float, integer, and there's a float. You might have a string, which is kind of a little bit of a tricky in-between case, but we've dealt with all of those, and they really, this string really has a single value, which is this series of letters here. We'll just kind of think of it that way for now. But a list is different. Why is it different? It lets us store several different values, and I've made them all integers here, and that's typically what you might see. You usually have the same thing repeated throughout the list. Sometimes people explain it as a filing cabinet. So inside of each drawer that you can pull out, you can store a value. And how do you manage these values? How do you deal with them? How do you get the information in and out? Well, you use what's called an index. So this value here, this index here, I should say, is 0. We have we start counting from 0. And so let's just run this and look over here for a moment. Here is our variable nums, and it says it's a list, and it has all those values in it. But if I use the square brackets with the index, I can ask, hey, give me the value that's in drawer 0, which is the first value in the list. What's the next one? Well, that's nums 1. It's the value 3. And you can see that we have 1, 2, 3, 4, 5, 6 values. But because we started counting from 0, the last index will be index 5, which gets us that last value, 31. If we asked for the value at index 6, we would get an index error saying that that value is out of range. So lists are really useful. They're very similar to arrays and other programming languages, at least in what we've done so far, but they can do other things. But if you see someone talking about, or you see some processing that's dealing with an array, you'll notice some real similarities. One thing we might do with a list is we might loop through it. So we might ask for, what are all the numbers in the list of nums called nums? And so this is not new, I don't think, for my students. We've used for loops. We've looped through strings before, and this seems to be doing a similar thing. It grabs the first value and it pulls it out, stores it in the accumulator variable n, and then runs the code inside of the block, the indented block. There could be many lines of code here, just the one line. prints out the value, and then it continues because there's only one line there. It goes to the next value, it pulls out the value 3, places it in the variable n, prints it out, and so on until it reaches the end. Now, we could do this another way. We could that's kind of looping through by value. We're iterating through by value because each time the value gets pulled out and automatically placed in this variable for us. But because we know these are also, that we can also access these values using an index, then we could, if you're familiar with the range statement, let's call it I because it's going to be an index, we could generate all the correct index values, by using range 6. Let's just print let's just print the indexes themselves. So that's printing out 0, 1, 2, 3, 4, 5. Those are all the indexes that you could use in this list. And now let's actually use that index to print out what the contents of the list is at that index. So there you can see the index values 0 through 5, and here you can see the contents of the list, what the values are at each of those index positions coming out. Okay, so there's more things you can do with the list. We certainly need a better video that will look at lists a little more in depth. You can add a value, so that's called append. And if you just, do we get that? Yeah, so if you do the dot operator and the tab, you'll see there's many methods here associated with lists, and we'll talk about a few of them as we work through some of these things. But let's just append a value. So there's a value, and when we look at the list again, you'll notice that 31 is no longer the last value. We've tacked on an extra value, 2, 3, 4, 2. If we want to know how many values are in a list, we can use the length function, or len function, length function, and it tells us that there's 7 values there. And the last thing I think I would say about a list is, not that we need it. So let's stop there. Let's not stop there. Let's take the next big step. We want to do tic-tac-toe. You could imagine, storing a tic-tac-toe board, I might call it a grid, by just having, 3, 9 values here in the grid. And we could loop through and figure out where to draw an X or O based on this based on these 9 values. We can map these. These can map to the top row. These can map to the middle row. And then that could go to the bottom row. We can make that work. But instead, I like to just think about it just a little differently. We'll talk about a list of lists. So it's kind of like the equivalent of a 2D, two-dimensional kind of list. So this is going to be a row. So here's a row that will happen in our tic-tac-toe board. And if player 1 plays that first position, then we would change it and it would look like that. And if player 2 played the position on the right, well, that would be index 2, we'd drop a 2 in there and it would look like that. You can see how we can use that to store that information. But what's this two-dimensional thing? Well, what if we have a grid where in the list we actually have a list? This is definitely just similar to what I was typing before, but there's an important difference here. So I kind of spaced it out a bit. Hopefully you can see we have a list called grid. And it actually contains, I wish I could ask the question, how many things does this grid contain? How many values does this list contain? When I ask for the length of it, what's it going to say? So let's just see what that says. So I don't know how many of you would have thought that would have been 3, because it looked like 9, because this one up here, if we had asked, would definitely have given us back 9. This one gives us 3, and the reason it gives us 3, if you notice this comma here, these are the 3 values that are separated by these commas here. This is the first value. Now it itself is a list, but it's still a thing, a single thing. And this is the second thing, and this is the third thing. So that's why we see a length of 3. If we ask for the first thing in this list, we get back another list. We get this list back out of it. So if we remember that this in fact is a list, well then we could use an index on it. So for instance, let's use index 1, which would be, normally, remembering that this is this list, index 1 would be this middle value. And let's change that to a 2. Okay, and let's ask again that seemed to have changed. And what does the whole overall grid look like? Well, that 2 in that first list has changed. Let's change the last list. 0, 1, 2. So the first index 2. The second index, let's change the first value, 0, and make it a 1. Okay, so you can see some stuff here that might be useful for Tic Tac Toe. And if we were kind of trying to do some looping stuff with this, let's look at that for a moment, still in Replit. If I were to loop through this like we did before, you can see we do that. We iterate over this list, only 3 things in it. We print out a list each time. And we could also use a range statement for that. There's 3 things in the list, so we use the value 3. Remember, range starts at 0 as well. So to give you 3 things, counting up by 1, you would get the values 0, 1, and 2, which map perfectly to the index values of the list. So pretty sure this is all kind of consistently, it's intentional and consistent. So let's ask for the thing that appears at, keep typing that, grid at index I. So you see the same thing. But we could do one more, doesn't like that. Let's ask for the, let's pretend this is kind of a y coordinate. I hope that makes sense to you, because these are being kind of printed out vertically almost. So let's think of that as a y coordinate. So I'll call that y in range 2. And I'll ask for x in range 2, because I know each list itself, oh sorry, what am I doing 2 for? 3. Now I want, okay. Oh, slow down. Okay, so for y in range 3, did I just finish trying to explain that? I think so. And so for x in range 3, okay, so I'm going to print the value of grid, and it's kind of like the coordinate, the first coordinate is kind of y, because this is the first row, the first y, I think thinking of it as y, and then I'll print out x. So I'm going to print out all 9 values by looping through 3 times. So 0, 2, 0, those are the first that come out. 0, 0, 0, those come out. And then the 1, 0, 0. Let me do this once more, and then we'll switch to processing, and I'll try to speed this up a bit. Okay, so first of all, I'll print, I'll try to print the x values together on a line. And to do that, I will say print, same thing, grid, index y, index x. But I'll use this little additional part of the print statement, end equals empty string. So normally when a print statement is running, the thing that's printed after the end, after the print statement is a new line, which looks like \n. So that's the default setting if you don't specify what should be printed after the print statement. But here I'm saying don't print anything. So that's going to force it to not print a new line after those coordinates. Maybe I should have left a space there. But after it's finished the X loop, we'll just print an empty, empty string, which will generate a new line. So now we're starting to get something that's looking a little more like a tic-tac-toe board. 0, no one played top left. Player 2 is in the middle top row. I'm pretty sure we could loop through this way and draw our X's and O's based on this. So I won't do the full thing. I'll try to work from what we had here. I'll get rid of almost all of it, but I'll start with this. Okay, so we still had a game board being drawn just using these rectangles, and I'm going to throw the grid down in here now, and it looked like this. Even doing this by hand for larger game boards is not going to be ideal. There's better ways to do this. If you're familiar with lists, certainly some list comprehensions would be good at this point. And do that same loop I did before. And I'm going to pull out the value here. Okay, so the question is, if this value is a 1, then can we draw a x? That was the original value. I had done it that way. So I'll check for a 1, and it's an x. And if it's a 2, it's going to be an O. And I have to draw it at, so let's check for it. So let's just look in the grid and find out, hey, does that thing equal? Let's do the 2 first. It's the easier one, because we just say ellipse. Oh, okay, so let's draw an ellipse. You know what? Let's just put it at, it's going to be something to do with these coordinates. We're going to try to use those coordinates somehow. And I'll make it 100 by 100. We know this is 0, 0, but if this value was 0, 0, we actually want it to shift over to be the center. This is 100, 100. So I'm going to, but let's just think about this position here. This is 200, this line, x equals 200. So we definitely want these x's to go up by 200s. So we need to multiply those up by 200s. You know what? I'll show you what I'm trying to explain. Not very well. So let's just print out some zeros. You can't even see them because they're all up in the corners there. So they're all printing basically at 0, 1, and 2. So they're all like basically right on top of each other. We need to space them out. We also need them to shift down. So this x is really the index value, and these indexes are 200 pixels spaced out 200 pixels. So when it's 0, it's still going to print up here, and so let's see what that looks like. Okay, so that looks better. So it's kind of respecting that x variable and being but it's landing on the line. It has to shift over by 100 pixels, kind of just a simple translation. So this is almost like a scale here, and this translate. But and the same thing is going to have to happen for y, and it's the same numbers because it kept it the same. So, and it also doesn't. Okay, so and what if we were to drop a 2 in here and drop a 2 down here, and maybe try to make this just a little more like a game board. Okay, this looks right. 2's in the left and center of the top row, middle, and bottom right. This is good. So we should be able to do something similar for the case where it's the other player, player 1, which is an x. And here, I'm going to leave it for you to do. So I'm going to cheat. I'm just going to drop a square down. So there's no ones in there. And let's drop some ones in there. But you can work on that part. So you can make it X's, but I'm just making it rectangles. And, oh, well, so it's 100 wide, so I can shift those over as well just to make them centered. But that'll work. That's good enough for now. And so let's just move on to other stuff. Let's talk about clicking on the game board, because that's also going to be, this is a lot less code, you'll notice if you hadn't followed along. Let's look at mousePressed. Surely there must be some other things that are going to come up. Let's just print what mouse X and mouse Y is. Okay, now print only accepts one thing, only wants to print one thing, so we'll put those in a list. Now we know what we're doing with lists. Can really do that. What if I click in the center? This is 200, this is 400, this is 200Y, 400Y. So I should have clicked somewhere around 300, 300. These are all 200. If we used integer division, and I really, if it would be much better if you want to just stop the video now and just figure out a lot of these things on your own. That would be great too. So, but this might be enough to get you started. But we can kind of take what we want to do is we want to take our coordinates of where we clicked and turn it into the indexes of where these things are being kind of displayed on the screen. This is 0, y equals 0, x equals 0. This is y equals 1, x equals 0. So how can we do that? Well, if we have a number here somewhere between 0 and 200, if we divide that integer division by 200, we just get a 0, which actually gives us the answer we want. So just looking down here on the console and processing, this is 0, 0. This should be y equals 0, x equals 1. So I'm printing out the usual way, x comma y here. So we should see a 1 comma 0. This should be a 1 comma 1. This should be a 1 comma 2. And if you're looking down here, these are all printing out correctly. This is a really easy way to go directly to what the index value is. So let's just now this step you want to be careful, because it's not exactly a coordinate, right? It's an index in the list, and as it turns out, it's kind of like the rows are the first number, the y value. So I'm just going to flip that. All right, so let's use those as our indices, and let's just change this to let's just change these to ones automatically. Okay, so ones are rectangles, and you can see me clicking, and anything that isn't a rectangle is becoming a rectangle because I'm changing the grid at the proper index value, and I'm turning it to a value 1. We'd used a variable called turn before, and that turn variable, you can use to increment as so we'll just make this a global variable. I think it's really good to keep your global statements at the very top of the function. And then if turn was equal to 1, then turn is equal to 2. Don't do this. Don't do that. You don't want to do that. That's not what you want. Think about that if you've done that and you're stuck as to why you don't want to do that. Okay, so and let's just make them all zeros to start, because we're getting to the point where we're pretty confident our game board is working properly, the positions are correct. Empty game board, click here. Oh yes, this looks good. Stuff is happening. Way less code is always better. There's going to be bugs in here. Alternate turns. Let's look for a winner. Let's just check for any winner and print a message. Okay, so after we've drawn the game board, and I think I might leave it there because I think there's a lot to digest here, especially if lists are totally new to you. This is, just know that compared to what we'd normally do is spend some time practicing lists and Replit. I encourage you to do that, and play around with them in Replit and figure out how they work a little bit there, and then play around with processing. It's just a lot of playing around right now, figuring stuff out, trying to get things working, trying to remember to take it slowly and test and predict what's going to happen, and then look at it when you run the code. All of these are really important steps because it's really about trying to make sense of this stuff. All right, so we're going to look for a winner. Let's just look to see if these three values are the same. So these are all kind of x coordinates, so let me just loop through those, and let's just check at the first top row if that no, what am I doing? Sorry. Let's just check if this is equal to the position. Okay, so this is not really a thing yet. Let's just print this out. Okay, so what are we printing out? We're printing out, this is a strange thing to print. It's a condition of whether or not this is equal to this and at the same time is equal to this. We're checking to see if the list holds the same value at the first row in the first position, the first row in the second position, first row in the third position. Its top row is all equal. Now when the game first starts and they're all set to 0, that is definitely true. So we should see a whole bunch of trues coming out. All right. Then I'm going to play a circle. Let's say I play a circle there. You see this is false. This is constantly printing. So, and then I've just changed it to a win situation. It's printing out true. So this is definitely a way to check for 3 winners. Let's make sure it's not equal to, they're all equal, but it's not equal to 0 at the same time, because that's going to be, so that prevented that false true, like that false positive saying there was a winner before anyone had played. Now we're checking to see if the square can win, and it did. Okay, last thing. So what if we wanted to do that for every row? Well, every row would be looping through 3 values of y. So in other words, that's not 0 anymore. That's going to be, now this is going to do it 3 times. So it might be hard to see when we actually get a win. So I'm going to move that over. It's saying false to everything right now. But what if we put a win in the middle? Now you can see there's definitely some trues coming out. False is for these rows here, but true for this row. I mentioned there's some bugs. Here's one bug. I can keep playing on an occupied position. So I'll go down here, and I can click, there. So there's some truths coming out for the bottom rows. This is working. The idea is working. I'm going to stop there. That's a long video. That's a lot of information, but a lot less code, and really a much better way to try to build this game.